Welcome back to the deep dive. Today we're tackling portable power. We've got a stack of source material here on generators, the two main types anyway. Our mission: simple, give you the core knowledge you need, help you pick the right machine before, the next power outage hits. Because, let's be honest, reliable power isn't really a luxury anymore, is it? It's pretty foundational. Supports everything from your home office to, essential medical stuff. So whether you're thinking about blackouts at home or maybe you're planning some off-grid adventure, you really need to know which generator delivers what you need.
That's exactly it. We're basically splitting the generator world in two today. You've got your traditional generators, think of them as the old school workhorses, right? Been around forever. And then there's the inverter generators. These are the newer kids on the block. Quieter, cleaner power, much more suited to our electronic world. The whole point is to match the right power solution to your specific situation, your needs, and honestly, what you can't afford to lose when the power goes out.
Okay, good plan. Let's start with the workhorse then, the traditional generator. These have been the go-to for, decades. And the core function is pretty straightforward, isn't it? Burns fuel, spins an engine, makes electricity. Raw power for the big stuff.
Exactly. Raw capability is their main selling point. Looking through the sources, that's clear. They excel at just sheer power output, high wattage. If you need to run, say, a well pump, or maybe keep the whole house going during a big storm, or even run heavy tools on a job site, you need serious watts. And the traditional units deliver that. Plus, generally, they have a lower upfront cost, which is a big draw for many people.
Right, that lower sticker price is tempting. But the way they make that power, that's also where the drawbacks kick in, isn't it? It's all about how fast the engine runs.
Precisely. That's the absolute key difference. To get the standard 60 hertz frequency we need for our appliances in the US, that engine has to run at one speed, constantly. Usually it's about 3,600 RPM. And it stays there, flat out, no matter how much power you're actually using at that moment.
Okay, so full throttle all the time.
Yep. And that leads directly to two big issues. First one, noise. The sources consistently peg these things between 70 and 90 decibels. To give you some perspective, that's like having a loud lawnmower running nonstop right outside your house.
Ooh, yeah, and if the power's out for days, that's not just inconvenient, that's actual stress, constant noise pollution. Your neighbors probably won't love it either.
Absolutely not. It's a serious quality of life hit during an already stressful time. And the second issue stemming from that fixed speed, fuel inefficiency. Because it's always running at maximum revs, it's burning fuel at a constant high rate. It doesn't matter if you're powering a huge freezer or just charging your phone.
Okay, so it's just guzzling gas the whole time.
Pretty much, which really hits your wallet over time, especially during a longer outage.
You mentioned the budget benefit earlier, lower upfront costs for traditional, but if they're burning, 30 or 40% more fuel every hour, doesn't that initial saving kind of disappear pretty quickly if the power's out for a few days? That seems like a paradox, the sources point out.
It is the big paradox, definitely. You might save, say, $500 when you buy it, but you could easily spend an extra $1,000, maybe more, on fuel over its lifespan compared to an inverter. That's a calculation you really need to make based on how often you expect to use it and for how long.
Makes sense. And what about the quality of the power itself?
Right, the final big trade-off, power quality. That brute force engine method produces what the sources call variable power, or sometimes dirty power. Basically, the electrical signal, the sine wave, isn't smooth. It has fluctuations, voltage spikes, dips, what's called harmonic distortion.
And dirty power, what does that actually do to your stuff? Like your computer or TV?
Well, think of clean power, like smooth, steady water flow. Dirty power is like that flow having sudden surges and drops, maybe some grit in it. It puts stress on delicate electronic components, especially things with microprocessors. It can cause computers to crash, data loss. Or it can just shorten lifespan of your sensitive gear, laptops, smartphones, smart TVs, even modern furnace controls or security systems.
Okay, so if you plan on running anything sensitive like that during an outage, a traditional generator might be risky.
It's definitely a major consideration, a big red flag for electronics.
Which brings us nicely to the other side.
Yeah.
The inverter generator, the evolution, you called it. These weren't just designed for raw output. They were specifically built to create clean, stable power, right?
Right.
For the digital age.
Exactly.
Yeah.
And what's really neat is how the inverter technology basically addresses every single major drawback of the traditional models. It's a completely different experience. It still uses fuel and an engine, of course, but the process inside is much smarter. First, it makes AC power, like the traditional one, but then, critically, it converts that power to DC and then uses an electronic inverter, like a computer board, to change it back into AC power. But this time, it's a perfect, clean, stable sine wave. That multi-step process with the electronic filtering is the key. That's where the electronic safe power comes from.
Minimal harmonic distortion. That's the phrase you see. And it's not just about keeping Netflix running smoothly, is it? The sources really emphasize this. If you rely on home medical equipment, or if your security system going down is a non-starter, that clean power is essential. It's a safety feature.
Absolutely. For critical devices, clean power isn't just nice to have, it's a requirement. But for a lot of people, the biggest wow factor with inverters is the noise, or lack of it.
Yeah, the decibel difference the sources quote is pretty stunning. You said traditional was 70-90 dB, like a lawnmower. Where do inverters land?
Typically between 50 and 60 decibels. That's the difference between a roaring lawnmower and, say, a normal conversation, or maybe quiet background street noise.
Huge difference.
It's night and day. You can actually run an inverter at a campsite without driving everyone nuts, use it for tailgating, or run it in your backyard without making enemies of your neighbors. During a long outage, that quiet operation makes a massive difference to your own comfort and sanity, too.
Okay. Quieter, cleaner power. And because they have that smart electronic board inside, they also tackle the fuel guzzling problem we saw with the traditional ones.
They do, yeah. Through what's often called smart throttle, or eco mode. Remember, the traditional engine running constantly at 3,600 RPM. The inverter's engine speed automatically adjusts based on the electrical load. So if you're just powering a lamp and charging a phone, the engine slows right down.
So it only ramps up when you need more juice.
Exactly. It sips fuel when the demand is low, which drastically extends your runtime on a tank of gas.
So we're talking about making a gallon of fuel last significantly longer.
The data suggests they can be up to 40% more fuel efficient than a comparable traditional generator. This completely changes that cost calculation we talked about. Yes, the inverter costs more upfront, but you can often make that back, sometimes quickly, through fuel savings. And that's before you even factor in the cost of not damaging expensive electronics.
Good point. Plus, they're generally built to be moved around more easily, right?
Yeah, portability is a big design focus. Many are significantly lighter, more compact, often with handles or even wheels, much better suited for camping, RVs, or just moving it around the house, as noted.
And I saw something about connecting two together, parallel capability.
Right, that's another clever feature. Many inverter models allow you to link two identical units together with a special cable. This effectively doubles your available power output. So you can have two small, easy-to-lift units that you can use individually for small loads. Or connect them when you temporarily need more power, like for running an AC unit. It gives you flexibility without needing one giant, heavy machine. Scalable power.
Okay, that's useful. Let's quickly touch on a price difference again, just to frame it. Traditional models start lower, maybe $300 up to $3,000 or so.
Generally, yeah, though big whole home standby units can be much more. For portables, that's about the range.
And inverters. Because of the complex tech, they start a bit higher, say $500 up to maybe $4,000 plus.
That's a typical range, yes. You're paying a premium for the quiet operation, the clean power, the efficiency, and often the portability features.
So boiling it all down, it really comes back to balancing those key factors. Noise versus raw power output.
An initial budget versus the total cost of ownership over time, including fuel.
Okay.
The traditional gives you maximum grunt for the lowest upfront cost, but it's loud, thirsty, and potentially risky for modern electronics. The inverter gives you quiet, efficient, clean power, but it costs more initially, and individual units might have lower peak wattage unless you pair them up.
Got it. That really clarifies the core trade-off. So let's try and summarize the use cases to help people decide who should lean towards traditional.
Okay, choose a traditional generator if you absolutely need the highest possible power output for things like large central air conditioners, big well pumps, or maybe running multiple heavy-duty tools simultaneously. Also, if noise is simply not a concern, maybe you're on a large property or a construction site. And crucially, if the initial purchase price is your absolute number one limiting factor, and you only anticipate needing it rarely for short periods.
Makes sense. And conversely, who should be looking seriously at an inverter generator?
You should choose an inverter generator if quiet operation is really important. Think residential neighborhoods, campsites, outdoor events, tailgating. Also, if you absolutely must safely power-sensitive electronics, computers, home office gear, medical devices, modern appliances with circuit boards, that clean power is key. Choose an inverter if fuel efficiency and longer run times matter, perhaps for potentially multi-day outages, or if you need something genuinely portable you can easily move or take with you.
And I guess the reality is most homes now have a lot of those sensitive electronics, don't they?
That's the shift we've seen. Laptops, smart TVs, routers, security systems, even fancy coffee makers. The need for clean, quiet power is arguably becoming the default requirement for most homeowners today, more so than just raw output.
Which loops back to the fundamental why we started with. Needing backup power today isn't just about keeping the lights on anymore, is it? It's about preventing bigger problems. The sources really frame it as peace of mind against some very real modern disruptions.
Absolutely. We're talking about avoiding hundreds of dollars in spoiled food from your fridge and freezer, keeping medications that need refrigeration safe, maintaining communication, keeping phones charged, internet routers powered up so you can get information or work from home, making sure security systems stay online. And for anyone relying on powered medical equipment at home, like oxygen concentrators or CPAP machines, a reliable generator isn't convenience, it's a lifeline, a critical safety device.
So really, the investment makes sense in today's world.
The investment is fundamentally in your comfort, your safety, and your peace of mind when things go dark.
So, thinking through everything we've discussed, the core question, as the sources suggest, probably isn't if you need backup power anymore. That seems pretty clear. The real question for you, the listener, is which type fits your life? Is it the raw power and lower initial cost of the traditional workhorse? Or is it the quiet operation, the fuel savings, and the essential clean power of the inverter that will genuinely serve you best when you actually need it?
It comes down to matching the machine to your reality.
And maybe the provocative thought to leave you with, pulling directly from this deep dive, when you really calculate the lifetime cost of that traditional generator, factoring in potentially double the fuel use, maybe more maintenance, and the very real financial risk of damaging a $1,000 laptop or TV with dirty power. Does that cheaper upfront price tag actually end up costing you significantly more in the long run? Something to consider.